What does L mean? Like in the word?
It's an acid of some
No,
sort.
yeah, but like L. What does L stand for? What is that?
It's a very long. It's like that long. Right.
Bahana.
It was invented by, I want to say,
Jesus.
Swiss or an Austrian scientist, and it was made to people with very, 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 very bad mental illnesses. They thought that it would help with
Would
that.
make it worse.
Um,
They're like, oh yeah, they have hallucinations. Put them in acid.
all right.
Don't remember.
I did make it cold. It should be very cold right now. All right. So, as I was leading on earlier, this is the calendar. We got nothing for 2 weeks. Like there's no quizzes. We have no quizzes or tests for a while. Notice middle of next week we have something called a review. Chapter 6 is not, or chapter 7 is not going to get out of hand. Like we're not going to wait for 3 weeks to find out that you guys don't know what you're doing. Right? So we're going to take a pause on Wednesday. And by pause, I mean like we're not going to do sit here and take a nap, but we're going to do a review so that we're not waiting until the very end here to find out that you really needed help on what we did today. I usually don't have kids have a problem with what we're doing today or tomorrow. They usually do pretty good on this stuff. But as we go forward, it becomes a little bit overwhelming because there's a lot of stuff in this chapter. And then if you try to add the new stuff with what we're doing today, it just becomes a bit too much. So far, all we've done basically is complete the not complete the fraction, but get rid of fraction, clear the fraction. Here's your homework. Notice what it says. Right? It says find the LCD and extraneous solutions. That's it. Well, I gotta explain that to you. When you do your homework tonight, as I said, the smart kids will probably be able to figure out what we're doing tomorrow. Well stated. Rylan actually did pretty good on his your test.
I did awful.
I did all for it.
I was fully expecting average.
I did awful. Please, that means I got a bump.
Yeah.
Did I do
Did
awful?
I fail it?
I got average.
All right.
Did I fail it?
I was proud of you, Rylan.
Wait, really? I did awful.
Yeah.
Well, I mean,
I thought there was a good chance that you wouldn't, but from what you but what you've shown me in class is like that's what you're capable of doing. So I was happy.
Did Landon do good?
Landon has an ability to always do well on multiple choice tests. And if you notice, Landon was one of the last persons to finish as well too. So I haven't had everyone finish. So right now there is a girl that's leading the way in scores.
Josie.
She hasn't finished her test.
Oh, Hannah O'Reilly.
You are correct in your guess.
Brandy.
No, Hannah
One of those. But
Riley.
we'll have to see what Josie and Anna do, see who's topped off here. All right. Okay. I'll go ahead and spoil it. Tomorrow you're gonna do the instructions.
Oh.
Tonight you're just gonna find the LCD. You're doing half of the work. Tomorrow will be the other half, which is now you solve the equation. Oh, by the way, tomorrow is ridiculously easy because you've already done the hardest part, which is find the LCD and the extraneous solutions. Okay. In the big scheme of things, if you pay attention, today is not hard at all. It's a pretty straightforward class, but you do need to pay attention. Here we go. Okay. We did this last chapter, fractional equations. In fact, we had you add and subtract fractional expressions, not equations. The only difference now is we're solving equations that have that same look and feel of ugliness, like really ugly looking fractions. Okay. All right. So last class, and by last I mean last week, we took an equation, we cleared the fraction, we turned it into a nice friendly equation, we solved it. We did that. Okay. The steps were step number 1, you found a common denominator. By the way, this might literally might be the one that Kaylee, you and I did yesterday. No, it's not. Different common denominator. Oh, what's common denominator?
It's
3, 4, and 5.
I mean, like 60.
60?
Yeah.
Right? Is that the smallest one they all go into? I think so, right? So 60, right? 5 goes into 60, 4 goes into 60, 3 goes into 60. Then we multiply everything, all 3 fractions by 60, right? This is the messy step, right? You do need parentheses, right? If there's a negative involved, it changes all the signs if there were parentheses here. The nice thing is 60 divided by 3 is
30.
60 divided by 3 is, and then distribute 20 to the inside, and we get, okay, 60 divided by 4. Oh, wheels slow down there.
Oh, it's 100,
Oh.
20, 200, 240.
Not multiplied, divided. 60 divided by 4?
13.
Close.
14.
15.
I was
15
so
times
close.
x is 15x. 60 divided by 5? Distribute. All that stuff turns into that, and then we solve that equation. Okay. So all that stuff is just to get to a nice friendly equation. We combine like terms, we move x's to one side, we solve. Okay. That was your homework and what you guys are going to turn in tomorrow. Okay. Today we're doing the same thing except it's even uglier. Okay. All right. So today's class, it's the same thing. It's just uglier. What's the difference?
There's stuff on the bottom. Diarrhea.
Well, I had stuff on the bottom
I
here.
mean, there's X's on the bottom.
There's variables in the denominator. We did this last chapter, except it wasn't an equation. I said add those two fractions. How many people remember how to get the common denominator? If it was just this. Okay, that's what we're doing today, except it's with an equation. Now, big picture, if it can be factored, yes, right? If it can't be factored, no, okay? Big picture, we're going to clear this fraction and we're going to solve it. Okay, the only difference is we got variables in the denominator, but what you said was good. As we go forward, algebra 2, pre-calculus, calculus, absolutely 100%. Probably there's going to be things you can factor. All right, so today we're going to do this. Also today, we're not going to get to solve. We're only going to get to clear the fraction and stop and something new called extraneous solutions. Okay, those two things. So we got variables in the denominator. We already kind of know what to do here, but we certainly haven't applied what we learned in the last chapter to this one. That's what we're doing. All right, so clear the fraction to solve. Do you need to write this down? Do you remember this from last week? Okay, if you don't remember it, write this down. First thing is you find the common denominator. And I didn't say CD, I said LCD, the lowest common denominator, right? 240 on the one that I just showed you was a common denominator, but why use 240 if you can use 60? So we find the least common denominator, the lowest common denominator, step 1. Step 2 is you multiply everything by that common denominator. That's the step where generally we make mistakes. Right? You reduce incorrectly, you multiply, you do distributive property incorrectly, you drop a negative. That's generally where the mistake will occur. Unfortunately, that's the second step. So you make a mistake in step 2, you carry it all through. You saw how many steps there were. You carry that mistake through, 8 or 9 more steps. And boy, does it turn it ugly. And this is why, rightfully so, Kaylee, you got frustrated is because. And I wasn't. I was happy. I was like, wow, she knows what she's doing, right? I was happy. She was not happy because she made a mistake like step 2. All right. Step number 3 is you solve the equation. That's one word for a whole lot of stuff that can happen. That could be 5 or 6 steps just to solve it. Generally, the intermediary steps for that one little step 3 would be you simplify each side, the left side and the right side, and then you move your x's to one side, and then you solve the 2 steps. Okay. We got one extra step. You're going to have to go back, and I'll explain this better in a second. You got to go back to the original problem, and you got to find the extraneous solutions. Big word, I'll explain here in a second. And you exclude those numbers from your final answer. All of these answers now will say something like, for instance, x equals or x cannot be the value 2 or 3. Right? It'll make more sense once we see it. Oh, by the way, this is a very easy step. Very easy. I saw 2 people, I forget who it was, but I remember seeing this question yesterday on a test. It was on their thing. They were like, what is the extraneous solution? And I'm sure you're like, what does that even mean? All right, you ready? All right, let me show you how easy this is. All right, write this down, box 2. This is the definition of extraneous solution. It's solutions that don't satisfy the original equation. All right, that's a math teacher giving you a definition. So here's a better one. What values of the variables, plural, in the denominator would make the denominator 0? Because remember, you can't have a fraction with 0 in the denominator. So I'm looking for numbers that would turn the whole denominator into a 0. Can't have that. Those are called extraneous solutions. We're looking for numbers that will make the denominator 0. This is a really easy step. In fact, writing the definition is harder than doing it. Hey, Rowan, remember the conversation we had yesterday? You're doing it. Everybody good?
Is there an English?
Yeah, we're gonna see what makes the bottom number 0. What would turn the bottom of the fraction into a 0? You can't have zeros. X can be 0, but the whole bottom of the fraction can't be a 0. It makes more sense once we do an example. Like I said, this is really simple. This isn't hard. Takes you longer to write this than it will to get to the answer. The answer typically just involves a little bit of adding, subtracting, and multiplying or dividing. We okay? All right. So sometimes this is ridiculously easy. You see the equation? Do you see you got a variable in the denominator? All right. Who shall I pick? Class, who am I going to pick on? Who? Rena's going to get it.
Oh, Piper. Me.
Piper.
I'm so sorry.
What number would turn this bottom into a 0?
What? Like,
What would turn this into a 0? Like, what would X have to be for the whole thing to be a 0? What would X have to be a 0? It would have to be 0. Remember I said it's sometimes ridiculously easy? If there's just a variable all by itself in the bottom, guess what the extraneous solution is? X can't be 0, right? You cannot have a 0 there. Yes. All right. X cannot be a 0 there. If X was equal to 0, if you found out this was the solution, it can't be the solution because that would say 3 divided by 0. That doesn't work. Okay? So sometimes it's ridiculously easy. If you see X by itself, one of your extraneous solutions is 0. You can have more than one extraneous solution. Hey, okay, you ready? You see you got 2 different times. You got an X in the bottom. Watch how easy this is. Step number 1 of this process is to find extraneous solution. You look at the denominator. Does this have an X?
no.
Don't care about it. Does this have an X?
Yes.
What would X have to be to turn this whole thing into 0?
-4.
If X was -4, this whole thing would be 0. Do you see that? For those that can't do that in their head, then you take the denominator, 4 plus X, set it equal to 0, and solve that.
It'd have to be 2.
That would have to be X is equal to -4. So X cannot be -4. Most people do that in their head. I usually don't even write this. Okay. Tristan already said, well, for this one, X can't be
2.
You got it. Like I said, extraneous solutions are not challenging, but you do have to be. It does have to explain what you're doing. So that can't be a 0. Well, 2 would make it into a 0. If you have to do this, well, then okay, it's just a one-step equation. X cannot be 2, and you said X cannot be -4. All I did was take that and solve it. X gives. You got 2 extraneous solutions. If you have 2 denominators that have a variable, you're going to have 2 extraneous solutions.
That's all.
Unless this is literally X minus 2, X minus 2. If they're literally the same denominator, well, then it's just 1. That is literally it. Not the whole class, but that's literally extraneous
Is
solutions.
that all that's asking for?
Right. Yeah, that's half of what we're doing today. Now, it can be a little bit more complicated if there's another number attached to X. Like if it was 4 plus 2X. Okay, then it's a 2-step equation you got to solve. Okay, but it's still a pretty simple process. I take this. Some people can do this in their head. All right, can you do that one in your head? Can you set that equal to 0 in your head and solve it? Some people can do this.
-2 times 2.
Okay, so some people can do it in their head, right? Other people need to take this whole thing, set it equal to 0, solve, subtract 4 from both sides. divide by 2. I mean, Landon did it in his head. Rylan did it in his head. Right? But be careful. A lot of times you're like, oh, x equals no. This is what it can't be. It can't be -2. I don't care if you do this. I literally, you're an Algebra 1, right? An Algebra 1 student should be able to do a two-stepper in her head, as long as they're nice, friendly numbers. These are both fractions, okay, all bets are off. With nice, friendly numbers, you can do that in your head. I wouldn't mark you wrong for, hey, where's your work type thing. No, extraneous solution is -2. Notice he did it the opposite way. He didn't do this. What did he do? He asked himself, what times 2 would be equal to 4? Right? Would be the opposite of 4, I should say. What times 2 would be the opposite of 4? -2.
Division is just easier.
Agreed. All right. So, box 3, grab your pencils. Let's just do this real quick. Hey,
X.
upper left, what can x not be? So you write x cannot equal 0. For the first one upper left, that's it. Anyone lost on that?
Yes.
Well, if x was equal to 0, you'd have 1 over 0. You can't ever have 0 in the denominator, ever. Now, be careful what I just said there. You can have a 0 in the denominator. Check it out. Look at this one. X could be 0. 0 minus 3 is -3. That's perfectly fine. But there's a value for x that x cannot be. What, for this one right here, what can x not be?
Negative. Yeah, 3.
And x can also not be, and x can also not be, not -1, +1. So this one has 3. Can't be a 3, can't be a 0, can't be a 1. Who's lost? Because there's a lot of people in here like, okay, I got this.
So is it okay if I write it in this form too? Or do I have to?
You can. So what he wrote is x it can't be 0, x can't be 1, x can't be 3. That's perfectly fine. Most of us are lazy. We write like this. Anna, we're looking at the denominator, and we're asking ourselves, they're called extraneous solutions. We're saying, what can x not ever be? If x was a 0, you'd have a fraction over 0. That doesn't work. What else can x not be?
2. -2, sorry.
Okay, pretty easy. Notice we're ignoring the numerator completely. Okay, so it can't be -2 and it can't be 0. Last one, x can't be
-3.
not -3,
Yeah, -2.
not -2, +2. All right, if we set this up as an equation, we'd have 3x minus 6 equals 0. Add 6 to both sides. 3x equals 6. Divide by 3, and you get x is equal to 2. But that's what x cannot be. X cannot be -2. Oh, I'm sorry, +2. Why did I say -2? Okay. Got it? Extraneous solutions are simple.
That would be an algebra.
All right. No. We will, like I said, chapter 6 is the hardest one. We're done with that thing. Things are going to get not super easy, but they're going to get relatively easier. By the way, this is new, right? Every day you're going to learn something new. So that's the challenge of Algebra 1, is that you learn something
Can we
new.
do this on our own?
Yeah, box 6, box 4. Do box 4 all by yourself. What can x not be for each one of those? Chris, you got this under control? What? Debatable? What would turn the denominator into 0? No. I mean, yes. No. If x was 2, then 2 times 2 is 4. 4 plus 4 is 8. You wouldn't get a 0. Yes. Everybody struggling? Chris, you're just making your hand move.
Well,
Chris,
Swear word.
let's do this one together. What can x not be? What can x not be?
2.
If x is 2, we're fine. 6 divided by 2 is 3. That's a perfectly fine answer.
How about 0?
X can't be 0. How about this one? What would x have to be to turn the whole thing into a 0?
-2.
-2 times 2 is -4. Perfectly fine answer.
Wait, how?
Keep talking. Haley, keep
What?
talking.
No, it's not Haley, it's Julie.
Oh, Julie. What?
Anyway, how the heck are you getting 2 out of 4 and X?
Do you see the upper left one here?
The one with 6 over X?
Yes. So I'm just
Yeah.
looking at the denominator. The denominator in that first fraction is X, yes?
Yeah.
So what would X be if the whole denominator was a 0? It would be 0, right? If X was the number 0, then you would get 0 in that denominator. You can never have a fraction where the answer is 0. So what we're saying here is, I don't know what the answer is to the whole equation, but I do know that X can't be 0. It might be -1, it might be 14, but it certainly can't be 0. Okay? If you
But if
actually
X, but if it can't be the number, then why is it the answer? Because like,
it's not the answer, Julie. We're not getting to, that's tomorrow's class. We're not getting to the solution. We're just finding out what X can't be. By the way, if you were to take your graphing calculator and you graph this thing, you would get a big empty spot. The graph would be a shape. And at X value 0, you'd have an empty spot. Like the graph would stop, you'd have an empty spot, and they would pick up on the other side of +1. These are called holes, right, in your graph. And what we're saying is that X can't be the value 0. Yeah.
So for the homework, do we just have to find out somewhere? Or do we have to-
LCD and extraneous solutions.
So we don't have to take that?
Not yet. That's tomorrow's class. All right. I didn't want to do too much in one day. Plus, this is easy, low-hanging fruit, as the expression goes, right? Low-hanging fruit means it's easy to do. You got an answer yet, Chris? What X can't be for this one? 0. Right? So it's 0 for this one. It's 0. Well, it's just one answer. So we're not saying, Julie, what the answer is. We're saying what it can't be. That's the extraneous solutions. All right. Who's got lower left answered? What do you got,
X can-
Sarah?
4.
4. X can't be 4.
Here you go, next one.
Lower left. If X was 4, you get 4 minus 4, which is 0. So you can't have 0 in the bottom. Okay. Hey, we can have 0 in the numerator. It's fine, right? Hey, if the answer is 6, 6 minus 6, we get a 0 on the top, perfectly fine. We just can't have a 0 in the bottom.
So
Upper right
X cannot equal 0 or -2.
or -2, right? And it doesn't matter the order. I will always write mine from least to greatest, but yeah. You got the last one? What do you got?
6 or 0. Oh,
6 or 0 cannot be. Those are extraneous solutions. Believe it or not, as you go up into higher level math, I don't know if you guys want to take pre-calculus senior year, but if you take pre-calculus senior year, this is a big part of pre-calculus. Hey, what are the extraneous solutions? Why? Pre-calculus has a lot to do with what is the shape of the graph. They won't be nice, pretty, like straight lines. It'll be weird stuff. And we're interested of where are the holes in your graph, right? Because if you're building a rocket and this is the formula for how much power you're using, you can't plug in, a value of your input as a 0 because your whole rocket blows up, right? You can't put a 0 into this equation. If you're writing computer program and this is a formula for something, you can't ever have, hey, how many kids do you have? 0. Your computer, literally, your computer crashes because you get a 0 in the denominator, and you can't have that in math. Okay? Extraneous solutions, as you go up in higher level math, have a great importance. Okay, we've done half of it. The second half is, well, for some of you, it'll be as easy as the first half. For others of you, this is where you're running the problems. Yeah.
What was the denominator? Do you mean like 2 and like 4?
Except that it's going to involve variables this time. Okay.
Oh.
So recall, right? When we find a common denominator, we're looking at all of the denominators and we're asking ourselves, what do they all go into? Pretty easy when that's a 2. If this was a 2 for X, what do 2, 4, and 12 all go into? That's the least common denominator, right? Comes a different story when there's a variable. Do you remember what you did last chapter? There were 2 cases. There was one when you just had a variable by itself, and there was another case when it was something like X plus 2. Okay, we'll look at both cases. Okay, here are the 2 cases, box 5. You don't need to write everything down here. One case, look, check it out. I just have an X. Hey, Rowan, supposed to pay attention. I just have an x. And over here I have I got more stuff. I got x minus 2. 2 different cases. Are you ready? I had like 2 people shake their heads. Yeah, I remember how to do this. Anybody? What's the common denominator?
3.
I got 12x. I got 3.
Wait, no, 12x.
Oh, I got 2 people for 12x. Oh, I got a bunch of people for 12x. Yeah, it's 12x. So here is the rule for the ones that have, hey, they're either numbers or there's one variable all by itself, right? I ignore the variable and I look at the numbers. Hey, what's the common denominator? Just between 4 and 12, it's 12, okay? And then you attach on the highest power of the variable. Like if there was an x and an x squared, you'd pick x squared. Do you remember that from chapter 6? You have the common denominator of the 2 numbers in the denominator. 4 and 12 would be 12. And then you look at all the variables. Well, there's only one. But if there's more than one, you pick the one that's the highest power. Hey, if there was an x and an x squared, you'd pick x squared. So if there was an x squared, it would be 12x squared. But since there's only an x, right, that's the x. And then the common denominator of 4 and 12. I should make those 2 different colors. And then you just simply do some math. Okay, the second one over here. I did make these different colors. Same thing, ignore that. 4 and 12 would be, so it's 12 and that whole darn thing. Remember doing that?
So you do the biggest number times
Well, not the biggest number, but the common denominator of the numbers and that whole darn thing. So it would be 12 times x minus 2.
and then would you just change everything like you
We're not going to do the distributive property because, as Sierra said, maybe something will cancel if we're lucky. Okay. All right. So for this one, the smallest number that 4 and 12 go into is 12, and well, x is x. We want the highest power. In yellow is what I might write down for box 5. These are the 2 cases.
Well, I mean, if you were to try to solve the equation.
Here's the big picture. What we're doing is we're finding the common denominator. Well, we found the extraneous solutions. We find the common denominator, and we're going to multiply everything by the common denominator. That's going to clear the fraction, and then we're going to solve it.
Okay.
So tomorrow, right, we're going to take what we did today, and we're going to do it. Hey, you found the common denominator. Now you're going to do that. Like I said, the smart kids are like, well, I see where this is going tomorrow. I'm going to give you the same ones for homework. You're just going to multiply everything by the common. That's the one that requires the most work. I would like to do that in class, right, so that we get a lot of practice. Smallest number that the numbers go into are in both of those. The highest power of the variable. You won't see too many of them. Most of the time they'll look like this. But say, not in that geometry, but algebra 2, you're going to get like an x squared, an x cubed. You pick the x cubed, the one that's the highest power. Over here, generally, there might be one of these that says x minus 2. But if there's 2 of them, x minus 2 and x minus 4, it would be both of those multiplied together. X minus 2 times x plus 4. You'll see an example here in a second. Is everybody good?
Yeah.
All right, let's see how that works. Okay, well, we already did this one. Common denominator is 12x. So following those rules, well, we take the variable to the highest power. Well, it's just an x. And we take the smallest number that both, I should be blue right there, that 4 and 12 go into. So it's 12x. That's the that's the common denominator.
So you would times.
And then we would, well, don't get ahead of the horse, but then we multiply everything through by 12x. Things would cancel, and you'd be left with this nice, easy, non-fractional equation that you can solve pretty easy. That's what we'll do tomorrow. Okay. All
So
we're
we're
doing
just
today,
finding-
find the common denominator, extraneous solution. What's the extraneous solutions?
I don't know. I wasn't here.
X cannot be 0. So x can't be 0, and the common denominator is 12x. That's tonight's homework. Okay. Okay, here we go. You always look at the numbers. 4 and 12, that would be, you take anything here, you multiply that 12 times whatever's written right there. And it's got to be in parentheses. And don't do the distributive property. Okay. The reason why we're not going to do the distributive property, because hopefully some things might cancel, and they will because we did it this way. Rowan said the extraneous solution was 2, right? So tonight for homework, the LCD is 12 times x minus, where's my 12? 12 times x minus 2, my extraneous solution is 2. X can't be 2, and the common denominator is 12 times quantity x minus 2. Cool? All right, let's do one. I wish my cat was that nice.
You have a cat?
A mean one.
Can you see a picture of it?
I'll show you a video of me trying to pet it tonight.
Oh.
I mean, it just is. It looked at me like, what? You're not touching me. All right, 4 and 4.
It's 4x.
Okay, well, like I said, so here's the problem with Algebra 1. Some people catch on this like that. Other people need a bunch of examples. 4 and 4 would be 4. Well, x, the highest power is x. So the common denominator would be, well, 4x. If you want to get a head start, like I said, I wouldn't recommend it, but if you want to, well, tonight for homework, then you're going to multiply everything through by 4x and solve the equation. It's just a little bit too much to do. One shot. Okay. Box 6. Here we go. Box 6. Box 6. Box 6. Hey, 2 and 5. 2 and 5 would be 10. What's the highest power of x? So the common denominator is. I'll go ahead and jump. What's the extraneous solution?
Can you go through that?
What would x have to be to turn the whole thing into 0, the whole bottom number into 0? So if x was 0, the denominator would be 0, right? So we're saying, I don't know what the answer is, but I do know that x cannot be the number 0. If x was like, we solve this tomorrow, and we find out that x, we won't, that x was 0, that can't happen because you would originally have 5 over 0. You can never have 0 in the denominator.
But they said it's 2. Why wouldn't it be 2?
I mean, it's not going to be 0. That's the answer. We're just saying that the extraneous solution, even before we start, is, well, it's not 0. Bigger picture of it, it's kind of lost now. It's 1 because we don't do it. But if we were to graph this sucker, right, we would find out there'd be a big hole at x value 0. All right, box 7. Here we go. Here's where I'll generally, the kids that really weren't paying attention, it's not 2, 4, and 5. It's just 4 and 5. It's not 2, 4, and 5. It's 4 and 5. 4 and 5 would be, and then tack on an x minus 2 and you're done. So it's 20 times x minus 2. That is the common denominator. That is what every denominator goes into. Okay? If you did, what will happen is, because remember, our very next step, I'll go ahead and do it for you. Our very next step is to clear the fraction. So if we take the first one, here's your first fraction, yes? We said the common denominator is 20 times x minus 2, right? And that's why you don't want to use the distributive property, because it wouldn't be clear of what cancels out. Now it's very clear. Oh, by the way, it just turns into 20x and you're done with that ugly looking fraction.
Would you still get the same answer?
You would, right? You're going to have a lot more work because it's not going to be clear to you what cancels. By the way, your first step would be to factor it, turn it back into 20 times x minus 2. Extraneous solution? X can't be 2. Okay, box 7. It's not 2, 1, 1. It's just 2. So it's 2 times. Oh, we got 2 things now. So it's going to be 2 times. And it doesn't matter the order that you write them. That thing times that thing. So it's going to be 2 times the blue things multiplied times 2. So 2 times those 2 things. Stop me if you're lost on that one.
So it's 2x. So we're doing the distributive property?
We're not doing distributive property because the very next step, okay, this is where it gets really ugly. This is why I don't want to do this a second day. You take this whole long thing, you can multiply everything by that.
I'm going to quit there. I'm sorry.
It's going to be that long.
I'm quitting.
But the nice thing is that we just saw things cancel. Once you're done with this step, then you're just left with non-fraction answer that you can easily solve. It's worth the effort. We okay? Chris, what's the extraneous solution? What can x not be? What would turn that into 0? Would 5 turn that into 0? Because 5 minus 1 is, well, that's not 0. What would x be to turn that into 0? 6 minus 1 is 0, right? What would x be to turn that into 0?
7.
7 minus 1 is not 0.
I don't know. I'm just guessing numbers.
I know you are, but I want you to try to think this through. What would x have to be to turn that whole thing into 0?
Just 1.
What would X have to be to turn that whole thing into 0? Oh, you're right. You got that one right.
Oh, okay.
Now, it's a different one. What would X have to be to turn that whole thing into 0?
Would that one just be -1?
So there's your two extraneous solutions. X can't be plus or minus 1. And you just got to go flat from both of them. All right. Yeah. And like I said, if you're wondering how some people are doing this quickly, it's they're saying to themselves, what added to -1 is 0, or what added to +1, or maybe they're thinking, solve that in their head. I mean, there's a lot of ways to think this through. Hey, add 1 to both sides, so X equals 1. Other people are saying, well, what subtracted from 1 or -1 from what number is 0? All right. Most Algebra 1 students do that whole thing. You don't have to do it in your head, but most Algebra 1 students do that in their head. All right, do box 8. Don't have a box 8? Better have a box 8.
He doesn't have a sheet.
I don't have a sheet.
Oh, sorry. You're welcome. Aiden, you got this?
Yeah.
How dare you wake me up?
These are the same ones.
No, they're not.
Oh wait, no, they're not.
They're similar, I'm sure, but
Yeah. Right.
Anna, you okay so far with this?
These
Why
are
don't you ask some
encouraging gang
questions?
violence.
Okay, that'll work.
That's what I do.
I don't post it till 8 p.m. though, so. Rowan, you got this?
Yeah.
Okay.
He's just not.
See, your behavior was very good today.
With mine?
Your behavior is normal, and for you, that's normal. That's
Okay.
questionable, but
Yeah.
compared to yesterday, when he was driving me batty.
He a baddie.
Yeah.
Do you already know how we did on that test?
I know how well you did. I know how well everyone but Anna and Josie. Well, I'm not. It's a number. It's not going to mean anything to you. Wait till
Did I
they
do
give me
good
this-
in my terms?
you did what I thought you would do.
Terrible.
Yeah.
You did not score the lowest in the class.
I did.
So that's good.
And
Were you that shocked?
the only one that I was
Really proud about?
no, I was proud of a lot of things, but I'm saying the only one I was just really happy that Ryland showed that he's where he's at, because I knew that's where you're at, and I was just happy that. So I make my own test. I grade your test. That's me making a judgment on you. But here's another person making the same judgment that I would make on you, and it was exactly what I thought. Average rank. Yeah, but. And I've said this many times for many people in this class. I mean, the only difference between average and above average is the above average kid either works harder or pays more attention. One of the two. Has nothing to do with intelligence and Algebra 1. It's just like, do you want it or do you not want it? Right? If you want it, you'll do fine in this class. If you don't want it, I can't make it. Come on, how can I make this sexy? There's nothing here, you know? Right? Okay, I got an X, but I mean, I need a few more letters, right?
He's got one X, but he needs a couple more.
There's nothing that geometry, I will say, hopefully you'll see next year when I teach it to you, that you'll see that there's a bit more life in geometry than there is in algebra. Algebra is numbers, and you got to be, if you don't think this is fun, there's nothing that I will do that will convince you that this is fun.
What
Right?
is on your water bottle?
All right, hey, back up here.
On the bottom?
All right, first one, what do we got? Common denominator, 4x. Extraneous solution, x cannot be 0. We okay? All right, bottom right, common denominator. Don't let Hannah answer everything here.
28.
What's the extraneous solution, Rowan?
0.
X can't be 0. Very good. This is your first hard one. I haven't really explained it to you.
Would it be like 2 parentheses 2x plus
8x.
4?
Wouldn't it just be 2x?
Yeah.
Oh, wow. You tried.
You're actually right, and this is not the LCD. This is a common denominator. I'm choosing not to get into the details here until Algebra 2. Turns out, for anyone actually looking, this is a common denominator. It's not the least common denominator. I'm okay with us at this level of Algebra 1 using this as a rule. It makes our lives a little bit easier. rather than factoring things all the time.
If I answer just before, that's okay.
Technically, the answer here is 2 times x plus 2 is the common denominator, but it's because if you factor it. All right. Last one. What do we got?
I could solve 3 of these equations.
Oh, extraneous solution is negative 2.
I don't why.
Yeah, but Rowan, what's 2 times 0? Plus 4? We didn't get a 0. So it's not 0. It is over here. 2 times 0 is 0. So we get a 0 there. Here, if you put a 0 in for x, you get 4. So it's negative 2 for this one. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. Last one, common denominator is?
4 times x minus 6.
Is
No.
it 4x parentheses x minus 6?
When there's variables, what do?
You combine them.
You wrote it in box 5. It says multiply everything together. So I take that variable and this whole thing and I multiply them together.
So x squared?
You could, but we said we were not going to do any distributive property. We're just going to write them next to each other multiplied.
4 times x times
So we got 4 times
x
times,
minus 6.
I got that.
right? See what I did?
I'm a genius, in fact, actually.
When you have variables, you just take those things. When I say multiplying together, okay, technically that would mean distributive property. I don't want you to do that because the very next thing we're going to do is we're going to multiply everything by this. And you're going to see why we didn't want to multiply because things will cancel. Extraneous solutions
X minus 6 or 0.
can't be a 6 or a 0. 0 or a 6.
Oh, the x minus 6 will cancel.
When we actually do the next tomorrow, you're going to see that's true. Okay? Notice if I multiply this supposedly common denominator by everything, you're going to see, hey, on this one, the x minus 6 cancel. On this one, the 4 cancels. And on this one, the x cancels. Right? Tomorrow's going to be slightly more complicated than our last class of the clearing the fraction, but not that much more complicated. All right, we put it all together. This is what it'll look like tomorrow. Okay, what's the common denominator?
4 times x minus 2.
Times x minus 2. So I found the common denominator. I'm going to multiply. Okay, here comes the ugliness. You ready? Right. We're going to multiply everything by 4 times x minus 2. It's going to eliminate these fractions. And you're going to be left with, look at my hands, something that looks like that long. You're going to solve that. But trust me when I say it ends up being not bad because it's nice, friendly numbers. You're going to have some 2s and some 4s, and it won't be that bad. Okay? All right. Yeah, that sounds like enough work. Yes? You can handle homework. What were the instructions for homework? And that's it. The instructions don't say that. I believe the instructions say solve the equation, right, by clearing the fraction or something like that. We're not going to do that. This is what you're doing. For those of you that are like, well, I can do this in about 10 seconds, then guess what you might want to do to get ahead? You take that, clear the fraction, and solve if you so choose. I would. All right, tomorrow we'll actually do. Anna, Josie, I got your homework. Yes. Got your homework.
I
From last
forgot.
Thursday.
I forgot to turn it in, so I'll turn it in.
I don't understand
No, we have that same day.
Wednesday.
We love that.
Yeah, it's not different weeks.
Hey, that's cool though.
Because I read through it. I'm just
Oh, right now, yeah, I want like a theory.
You have the highest score as of right now, but I don't know about Anna and Joseph. And even if you don't have the highest score, you did very well. It's very good. I think Brandy has the second highest score. What? I gotta wait for the bell. All right, let's see who's on. Julie, any questions?
No, I think I'm good. If not, I'll
Cool.
just go through and watch the video.
I'll have this video posted at 8 o'clock if you want to review it. Piper says, hey.
Hi, Pipes.
She can't see, the camera's right here.